Hi everyone. Today we're going to talk about central and inscribed angles very quickly. All right. So we are now working with circles, their angles inside, and a circle, as we know, the entire circumference of a circle has 360 degrees. So really, we're just going to be working with this reality with 360, with 180, and seeing what we can figure out about their angles. It's fairly simple. So I've got a couple circles right here from GeoGebra. And let's work with this larger circle at the moment. So you notice with this circle that uh, I'm going to create a 90-degree angle right here. All right, try to get it right at about 90 degrees. All right, and that's about as close as I'm going to get it. Okay, so this 90-degree angle, as you can see, we're drawing it from the center. So if you imagine the center of a circle, all right, and that center drawn out with two radii, basically it's going to intercept an arc. All right, so this guy right here on the edge, the green one, is an arc. All right, and arcs have angle measures as well. For example, this arc, the measure of this arc, and let's give this some letters. So this is A, let's call this O, and let's call this B, and let's call this C. All right, so the measure of arc A, O, B, all right, the measure of that angle is 90.1 degrees. All right, so we label this as 90.1 degrees, the arc itself. All right, that is how large that angle is. This guy right here, 90.1, well, it is really central. So we call this guy a central angle, and that's a E. That's a central angle, while this guy over here we call an inscribed angle. All right, now you might think these notes are really, a little too sudden, very quick, but it's actually rather simple. So a central angle is going to be equal in measure to its the measure of its intercepted arc. So if this is a 90-degree angle, then the arc measures 90 degrees. All right, but the cool thing about it is that this inscribed angle, which an inscribed angle, you'll notice its angle, its vertex is not on the center of the circle. It's actually on the circumference, on the perimeter of the circle. This inscribed angle actually ends up being 1/2. It ends up being 1/2 of the central angle. So you notice that the farther back we pull this angle, if we go all the way back to the circumference, we end up getting an angle half the size of the central angle or of the arc itself, which again was 90.1. So this guy's going to be 1/2. So the key factor right here is 1/2, 1/2, 1/2. All right. And if we can check it out by exploring a little bit more. So if I go ahead and extend this to be a 180-degree angle. So check out my arc. My arc is practically 180 degrees. All right. In other words, half of a circle. So you can tell how the central angle right here is 180. The arc is 180 degrees as well. But now take a look at your inscribed angle. All right. I've not moved this point, but it is now a right angle. It is now a 90-degree angle. All right. So once again, showing you that an inscribed angle is half of the measure of a central angle. All right. And the cool thing about this is no matter where I move this point, that angle is always going to be half of the arc that it intercepts, right? Half the measure of the central angle. So this continues to be 90 degrees no matter where I move it. All right. Same if I create an angle larger than 180. So if I make an angle of, let's say, 200 degrees, right? Notice how my inscribed angle is now a 100-degree angle. All right. So that's the relationship between inscribed and central. It is a 1-to-2 relationship, or a 1/2 relationship. And the only other thing that we learned right here is that this outside guy is called an arc, and that we measure an arc using degrees as well. So this green arc would be 200.21 degrees. All right. And that is basically all that you need to know as a starter for the basic angles of a circle.